Welcome back to All This Math. This is Professor Parker. Please, if you're here, hit the like button. Also, subscribe if you're not already subscribed. Share this video with somebody else when we're done, at least one other person. And if you got any questions or comments, put them in the comment section. All right. Now, also want to give a shout out to the ancestor, Harold Washington, mayor of Chicago, and shout out to everybody from Chicago. All right. Now, long division. Let's do this long division problem real quick. Now, long division, I like long division. Long division is the way I learned how to do division when I was in elementary school, like in the third grade, right? There are also some other methods. There's the partial quotients method, which I like too. There's the box method, which I also like. There's a couple other methods. I can't think of what they're called, but yeah, box method and partial quotients are the other two, probably most prominent, examples of division. But long division is, it's a tried and true method. All right. So I want to go over this example of long division. And first, let's talk about what these numbers are. This first number is called our dividend. That's our dividend. That's the number that's going to be divided up into different pieces, right? And the second number is our divisor. So we have a dividend of 563. We have a divisor of 3. Our answer is what we call the quotient. Quotient. The quotient. All right. So our answer is the quotient. Now, how do we set it up? We draw the long division symbol, right, which is called a vinculum. Well, the horizontal bar is called a vinculum. I don't know what the vertical line is called. Well, maybe the whole thing is called a vinculum, but I think I read somewhere that only the horizontal part is called the vinculum, actually. But the dividend goes inside the vinculum. Some people call it the house. And then the dividend goes outside the so-called house. So you do this, 563, right? And what we're doing when we divide is we're trying to see how many 3s can fit into the number 563. How many 3s, how many of the second number can fit into the first number? How many 3s can fit into 563? All right. So with long division, there's a 3-step process. I call it DMS because those are the acronyms for divide, multiply, subtract. Divide, multiply, subtract. And then you drop a digit down. Then you start the process over. Divide, multiply, subtract. So I probably should say 4 steps. Divide, multiply, subtract, drop. Divide, multiply, subtract, drop. All right, let's see what it looks like. So first we got 563. We want to break this up into different digits, right? So we start with the first digit, 5 divided by 3. Now we can do that, right? You won't always be able to do that, right? Because sometimes your first digit will be less than the divisor. And if that happens, then we want to then look at this. Instead of looking at the first digit, we want to look at the 2 digits together as a 2-digit number. But we don't need to do that here. We could do it here, but we don't need to do it here because we can actually divide 5 by 3. And we're asking the question, how many whole groups of 3 can fit into 5? That's the question we're asking. How many whole groups of 3 can fit into 5? I know 1 can fit. Can 2 fit? No, because 2 groups of 3 will be equal to 6, and 6 is more than 5. So 6 can't fit into 5 because 6 is more than 5. So we want to know how many, or what's the maximum amount of whole groups of 3 that can fit into 5? 1. You put a 1 right here. Then we're going to multiply. Multiply what? The divisor by this quotient right here. Divisor by the quotient. So 3 times 1 is 3. Where do we write it? Underneath of the 5. And then we're going to subtract. 5 minus 3. What is that? 2. Right? And then we're going to drop this 6 down and start the process over again. Start the process over again. So now we're going to say how many groups of 3 can fit into 26? That's a form of division. Basically, what I'm saying is, what is 26 divided by 3? By me saying that, how many groups of 3 can fit into 26? I'm saying 26 divided by 3. Those are synonymous questions. So how many groups of 3 can fit into 26? Now, if you know your multiplication facts, this is easy. But if you don't know your multiplication facts, this might be a little rough. So learn your multiplication facts. I implore you. Please learn your multiplication facts. Get them memorized. Practice multiplication. Practice division until you have them memorized, right? Like you know them like the back of your hand. All right. So because I know that 3 times 8 is 24 and 3 times 9 is 27. 27 is more than 26. So 7 groups of 3 won't fit in. No. 9 groups of 3, I meant to say. 9 groups of 3 will not fit into 26, but 8 groups of 3 will, because 8 groups of 3 will take me to 24. So I put an 8 right here above the 6, and then I'm going to multiply 8 times 3. That's my next step, right? Divide, multiply, subtract. 8 times 3 is 24. And I put the 24 right here, draw a line, subtraction sign. All right, then we do our subtraction. 26 take away 24. We got to know how to subtract also. That leaves us with 2. All right, Then this 3 comes down. This 3 migrates back down south. Think of it like that, like reverse migration, right? Reverse migration. Like if anybody seen the movie Sinners, you know what I'm saying? The Smokestack twins. They left Mississippi, went up to Chicago, came back down home. You know what I'm saying? Said Chicago ain't nothing but Mississippi with a bunch of tall buildings. That's what they said, right? So reverse migration. This 3 came back down south. All right. So now, what's 23 divided by 3? Or how many whole groups of 3 can fit into 23? Again, if you know your multiplication facts, this is easy. 3 times 8 would be 24, like it was right here. 24 is more than 23. So that means 8 groups of 3 can't fit into 23. But 7 groups can. 7 times 3 is 21. 7 groups of 3 can fit into 23. Where do I put the 7? I put the 7 right here. All right, put the 7 right there. Now it's time to multiply. 7 times 3, 21. Write the 21 underneath for the 23. Draw your line. Subtraction sign. What's 23? Take away 21. 2. Right? Now here we got a couple choices. We got no more digits to bring down, right? No more digits to bring down. We used our 5, 6, and our 3, right? We could stop right there and say, okay, the answer is 187, remainder 2. Meaning, what does this mean? This means that 187 threes can fit into 563. Because what was our original question? How many threes can fit into 563? 187 of them. 187 of them can fit in there with 2 left over, right? With a 2 left over, right? But that doesn't really mean it's 2 threes left over. This means that 187 threes can fit into 563 with a remainder of 2, with a difference of 2 between 563 and the total when you have 187 threes, because 187 threes is equal to 561, right? Because 187 threes would actually be a total of 561. So the difference between 563 and 561 is 2. So there's a remainder of 2, right? So another way you could write this is you could say 187 and 2/3. Now, why does this make sense? Because this tells us that 187 threes can fit into 563. And then that cushion between 563 and the 561 that 187 of them would make leaves you 2. So 2/3 of a 3. 2/3 of 3 can also fit. Because think about it like this. I love drawing tape diagrams, right? So this is 1, 2, 3, right? Think about the divisor 3 like this, right? If there's a remainder of 2, that means that 1, 2, right? This is 2/3. 2 of 3. Because the difference between, because again, 187 threes gives us 561. Think about that. 561. What's the difference between 561 and 563? 2, right? 1, 2, 3 makes 3 because we're dealing with groups of 3. But if there's a difference of 2, that means 2 of these, that means 2/3 of 3 can also fit. So 187 whole threes and then 2/3 of another group of 3s. So 2/3 of another group of 3 can fit in 563, right? That's another way to write the answer. Now, another way to write the answer is with a decimal, but that will require us putting a decimal point right here after the 7 and writing zeros and then dropping zeros down, right? And then we can do that for as long as we want, right? So that's the 3 main ways of expressing an answer when we do division, right? We can express it with, when we have a remainder, that is, all right? Express it with the quotient and the remainder. This number will be the remainder. What number we're left with after we don't have any more digits to bring down from the original dividend, right? Or we can create a fraction. Take the remainder, put it over the divisor. Remainder over the divisor. The remainder will be the numerator. The divisor will be the denominator. Remainder over the divisor. Remainder over the divisor. That's what 2/3. That's another way to get 2/3. Or I didn't show you this way, but we can start writing zeros and then you end up with digits after the decimal point. You will put a decimal point after the 7. So yeah. So that's that. So just a little long division. I just wanted to show you that and just kind of want you to familiarize yourself with long division if you're not already, or if you learned it 30 years ago or 40 years, if you're a parent, grandparent, uncle, auntie, whoever watching this, somebody godparent, and you want to kind of reacclimate yourself with long division, then I hope this helped. All right. So, again, shout out to the ancestor Harold Washington and anybody from Chicago might be watching this. And make sure you subscribe to the channel. Make sure you like the video. Make sure you share the video and go get some practice. You know what I'm saying? If you got any questions, drop your questions in the comment section. All right. And I might make a follow-up video just to answer your question. All right. Peace.